Hello students and welcome for Engineering Mechanics lecture series. Today we will discuss about the module number 2, that is Centroid. I am Professor Sagar Dhotre, Assistant Professor in Department of Applied Science and Humanities, Universal College of Engineering. I welcome all of you for this lecture series. We will discuss in this lectures we will discuss about the center of gravity, centroid, their different plane laminas and their primitive geometry shapes which we are uh, can be used for finding the center of gravity, centroid. The most important thing is the center of gravity. It is nothing but if you look in a figure, there are multiple forces or particle, each particle having its own weight, or you can say it having its own inertia, gravitational force. Now, whenever we combine all these particle forces or gravitational forces of these particles in a single force, that is the force acting at a particular point, which is the resultant of all the particle forces that can be applied, that is called as the center of gravity. So in simple word, the center of gravity is a point where the whole weight of the body is assumed to act. That is, it is a point it is a point where the entire distribution of gravitational forces, that is weight, is supposed to be concentrated. The term of gravity is usually denoted by G, and the value we know that 9.81. And the dimensions, or you can say there are three dimensional rigid bodies we are generally considered for this. Okay. Next one is the centroid. That is a very important thing because uh, we have to identify the centroid location with a different shapes. Centroid is a point where the whole area of a plane is assumed to be at. It is a point where the entire length, area, volume is supposed to be concentrated. For an example, if a human is walking over the floor and its center of gravity is not in a normal location, then what actually happens, it could not able to balance during the walk. So similarly, in the simple thing, that the whole volume, or you can say whole volume or whole area, has to be concentrated at a particular location. In other words, the centroid is a geometrical center of a figure where the terms of centroid for two-dimensional figures, uh, normally we are using in a centroid, that rectangle, triangle, circular, semicircular, and different type of shapes, which we will discuss further. Now, center of mass, it is a point where the entire distribution of the mass is supposed to be concentrated. Okay, so two things only you need to be understood, that is a centroid and center of mass. Okay. Next, you can look at the figure number 1, where the plate has been a circular plate having a thickness T, which is considered over here, and it having a different areas. Each we are considering few coordinate, or you can say elements, in between the plates, and we identify that the total weight W is equal to summation of all the weights of the particle, that is W1 to Wn. Okay, and we are considering the moment about these particles along with the y-axis. So applying the varingness theorem, we identify that the W along x direction is W1 x1, W2 x2, W3 x3. But what is the value of W? Value of W is nothing but the weight of all particles. Okay, So to identify the x distance of x location of that center of gravity, the formula is x bar is equal to w1 x1, that is the first particle's weight, into the x coordinate distance plus w2 x2 and so on wn to xn divided by the total summation of the weights. Okay. Similarly, the centroid area, let us considering the uniform thickness T having a density, mass density of that material is rho. A is the total surface area of that plate. So weight is nothing but mass into gravity. That is gravitational force. You can say m into g. Now, how we can identify, how we can calculate the mass, that is volume into density. Okay, and how we can calculate the volume, that is area into thickness. So the simple say, whenever you calculating any weight, area, thickness, density must known to you. Okay, so by putting the value of w into previous equation of x bar, okay, what we get a simple equation that whenever we have to find out the x coordinate of an centroid is equal to summation of all the areas into the distance divided by summation of area. Okay, so this condition is along with y-axis. Now when we taking the moment along with the x-axis, the moment related to x-axis is considered as 0 as a as per the Varignon theorem, because the distance is 0. Okay, so we are getting the distances of that particle in the y direction. Okay, by applying the similar philosophy, the similar process, we get a final equation for identifying the position in the y-axis, that is summation of a into y of I divided by summation of a. A is nothing but area, y is um, the distance. Now mathematically we can find out the expression which is shown x bar is equal to derivative integration of x uh, d in the derivative of a. Okay, so small area has been considered, that is dA, and integrated it. Okay, rather than this you can uh, understand the equation which is necessary to identify the x bar and y bar. Okay, next one, the most important few important points which we need to be remember during the calculation, or you can say consideration, uh, while calculating the center of gravity of any object. Let us say center of gravity of the geometric center of a figure. First of all, there are to be considered, there are various type of geometries are available. No one can be symmetric or unsymmetric, or different uh, different uh, cross sections, standard cross sections are available. Otherwise the combination, or you can say composition of this cross section is also available. So in standard geometries we exactly know the center location of that figure. Or if, for example, if you consider any circle as a geometry, the center location, center, we know that that is at the particular at, at the center. Okay, so similarly you need to be understand what kind of geometry and where is its center in a figure. For symmetric figure, the centroid lies on axis of symmetricity. Okay, and next, if the symmetricity is about x-axis, then y coordinate of CG, that is y bar, is equal to 0. Similarly, if y-axis coordinates are symmetric, the x coordinate are 0. If the given figure is having a more than two, three axes or more than one axis, first of all identify the symmetricity, then identify the various intersections of multiple geometries. Okay, in few cases like let's say a mobile phone. Okay, in mobile phone it is a rectangle plus four corners having a radius, right? So in this case there are one rectangle and four corner radiuses. Okay, you can say 3/4 of circle. So similarly identify the symmetric geometries and identify the unstandard uh, geometries first. Then centroid may or may not lie in the given figure. Maybe it might be outside the boundary and inside the boundary. If the axis of symmetricity is inclined 45 degree to the horizontal, in this case x is equal to x bar is equal to y bar. It means that the coordinates or value of those x and y will be same. Let us take an example of rectangle. Okay, now area of rectangle, we know, everyone knows about that, one half length height into breadth. Okay, so based on the equation which we have already studied, the y value, that is y bar. Okay, putting all the values and all the things, what we exactly we need to understand, we need to understand how to identify how what is the value of y bar. Okay, that is h by 3, as the x coordinates are getting, if triangle is symmetric in x bar, then x coordinates are 0, so only we need to calculate y coordinates, and the value of that y coordinates of center of gravity is y bar is equal to h by 3. Okay, b is the width, h is the height for rectangle, sorry, for triangle. Now the center of centroid of a semicircle area. Now one of the most useful geometry in the day by day life, you can consider any kind of rings and all things, so you will see such kind of shape in this geometries. So to similarly, the symmetricity along x-axis, along y-axis is the same. So x coordinates of the this geometry also get 0. Okay, and the y coordinates we have find out, that is y bar is equal to 4r divided by 3 pi. Okay, you just need to be understood about the standard geometry and their location of centroid. Next one, when we consider quarter circle area, in this it is not symmetrical with respect to x and y. So here the x coordinate as well as y coordinate we will get it. One more thing we have already discussed, that is if the angle between these is 45 degree, then x is equal to y. The same thing is applied over here. At 45 degree we found both are symmetric, and that's why the value of x bar and y bar is equal to 4r divided by 3 pi. Now next one we consider as a sector of a circle, that is a particular area only. You are not considering 3/4, one half or 1/4. We are considering the small angle, that is theta, or you can say small angle in between these two edges. Okay, for symmetric such kind of geometry, the value of x is equal to 2r sine alpha divided by 3 alpha. Alpha is the angle between, symmetric angle between these two edges. Okay, and it look like a triangle. It look like a triangle. Now, one more to summarize the few standard geometries, that is for rectangle, the value of x bar is equal to a by 2, value of y bar is equal to b by 2. In isosceles or equilateral triangle, x bar is equal to 0 as y axis is symmetrical, so the value of y bar is equal to h by 3. For right angle triangle, you need x and y values both. X coordinate x bar is equal to b by 2 b by 3, and y coordinate is h by 3. For triangle which is not equilateral, for that the value is again, because it's not equilateral but still it is symmetrical. In this case also the value of x bar is equal to 0, and you can directly use the value of y bar is equal to h by 3. Then semicircle, that is 4r by 3 pi, as we know that it is symmetric about the y-axis. Then the quarter circle, it is correlated with the 45-degree one. So the value of x bar is equal to value of y bar is equal to 4r divided by 3 pi. Now when we consider a particular sector, circular sector, and that we consider that the axis symmetricity along x-axis, okay, with an angle alpha in both sides. In this case, the area is equal to alpha r square, and your x quad x quadrant is having a value as the in y-axis it is symmetrical. So the value of x quadrant x dash is equal to 2r sine of alpha divided by 3 alpha. Okay. Now how we can find out the location of centroid in a composites area? We have already studied or we have seen the different standard uh, geometries. Now when they are compositing, it means when they are combined more than one geometry to create another geometry. Okay, so in this case we uh, follow this procedure to find out the centroid and location of centroid and the basically composite area also. So first of all, identify the different geometries inside inside the main geometry. We will uh, we will just take an example rather than discussing this. We will go with an example that will be much more easy to understand. So let us consider this figure. In this figure we seen that there are multiple edges, or you can say there are multiple locations are here. Okay, these are the edges. So in this, what is the standard one? What is the standard dimension for this? So in this there are two geometries we can see over here. Okay, first geometry is rectangle, and second geometry I will draw it with a different color. So second geometry is triangle. So we need to understand, we need these two areas to calculate the centroid and the location of this given area. Okay, so let us calculate the areas. So as I said, there are two different x and y values for for the triangle, or sorry, for the rectangle. The location of centroid is x bar and y bar for first one, and second one there is another x and y value which we need to be available for triangle. Okay, so based on these two values or these two combined geometry, we need to calculate the exact location of an centroid for the given geometry. Okay, so let's calculate the areas. For rectangle, area is equal to b width into breadth, that is 5 into 6, so 30 meter square is the area. So based on the values we can find out the x quadrant. So width उसका जो है वो 5 मीटर है, so divided by 2, and the height is 6, so 6 by 2. So the x1 quadrant is 2.5 and y1 quadrant is coordinate is 3 mm, 3 meter, sorry. So similarly we need to find the areas and coordinates for a triangle. So second area is triangle 1 half L into B, so that is 1 half 6 into 3, that is 9 meter square, and the x location is equal to, now in a x location it is not, it is uh, it is not at a location at the initial stage, it is after the rectangle. So the distance from the rectangle is to be considered. So the width of the rectangle is 5 meter, that is considered, plus we know that there is a height divided by height divided by 3 by 3. X quadrant we are considered as a symmetric, so it's a 3 by 3. So 5 plus 1 is equal to 6, and y coordinate, that we know that h by 3 is an equation, so height is 6 meter divided by 3 is, we get the y2 value is 2 meter. Now identify the exact center of gravity location for this given whole figure. Okay, now we are combining both. We are using both quadrants coordinates of a rectangle and triangle to identify or to locate the exact centroid of the whole figure. So x bar is equal to area into x1, that equation we have already seen, a1 x1 plus a2 x2 divided by a1 plus a2. Okay, by putting the values we will get x and y bar equation, values of x and y bar. So for this given geometry, the centroid coordinates are x bar is equal to 3.308 meter and y bar is equal to 2.769 meter. Okay, so I hope uh, based on the geometry you are able, you are basically understand how the procedure to be followed to identify the centroid coordinates for the given figure. So once again I will summarize the procedure. First of all, based on the figure, identify the standard geometries, like how many rectangles are there, what is the dimension, how many rectangle, triangle, circle, semicircle, quarter circle, or the circular section, whichever the standard geometries need available, just first of all note it down. After the noting these geometries, find out their areas and the x coordinate and y coordinate separately. Okay, after the doing for all the standard areas, you can identify the x bar and y bar, that is the final location, or you can say final coordinates of your centroid. Okay, I hope that will be the simplest example you have seen till time.